going to learn about finding the law of sines, okay? So it kind of gives all the directions right here that we can do. I find that people miss little pieces of the directions, so I want to go over it as a whole class, okay? Right triangle trigonometry can be used to solve problems involving right triangles. However, many interesting problems involving non-right triangles. In this lesson, you will use right triangle trigonometry to develop the law of sines. The law of sines is important because it can be used to solve problems involving non-right triangles as well as right triangles. All right, so we are going to follow these instructions, and at the end, we're going to come up with a formula for how to use law of sines, okay, just so we can find all the sides and angles for any triangle, whether it's a right triangle or not. Okay? All right, we're going to sketch an altitude from vertex B. Anybody know what an altitude is? It's like a line that goes straight up and down, right? But we're going to go from B straight to the other side. The nice thing about an altitude is it makes 90 degrees with the other side. Okay? This altitude creates two right triangles inside ABC. Notice that angle A is contained in one triangle, this side, and angle C is contained in the other triangle. Using right triangle trigonometry, we're going to write two equations, one involving the sine of A and one involving the sine of C. Okay, so sine of A, we know, is opposite over adjacent, over hypotenuse, okay? Opposite over hypotenuse. So we're going to say this altitude right here, which we're labeling K. So we're going to say sine of A is K over C. And then we're going to go sine of C is K over A. How are we doing so far? Use a different color? No. I think that light blue is just a little too light. Okay. So we drew altitude K, forming two right triangles. And then we used the sine of A is K over C, and the sine of C is K over A. Is that better, guys? I'm going to zoom out just a little bit so we can see. All right. Notice that each equation in question 3 involves K. Why does this happen? Solve each equation for K. Why do you think it happens? Why do they both involve K? When we look at the sine, why did both of these end up involving K? Yep, they both involve the altitude. They both involve the shared side. They both use the shared side, which is K. Okay, now we're going to solve. So if we look at sine A equals K over C, I want to have K all by itself on one side. So what is with K on this side of the equal sign? That's C. And it's being divided. What's the opposite of division? Multiplication. So we multiply both sides by C, and those cancel. And we get C, little c. It's important to make the capital letters distinct from the lowercase for this. Sine A equals K. And then if we go sine C equals K over A, we multiply both sides by A, right? So little a sine C equals K. So far, so good? Zoom in a little bit more. All right. Since both equations in question 4 are equal to K, they can be set equal to each other. Set the equations equal to each other. C sine A equals A sine C. Notice that in question 5, no longer involves k. Why not? Why don't we involve k any longer? Because we set them equal to each other, right? Okay. Write an equation equivalent to the equation in question 5, but regrouping sine A with A and sine C with C. Okay, so if I've got little c sine A equals little a sine C, how am I going to get the c's all on one side and the a's all on the other side? Well, what is little c doing to sine A here? Adding, subtracting, multiplying, dividing. What's the opposite of multiplication? Division. So I can divide by little c, and they go away. And I'm left with sine A equals little a sine C, big C, over little c. So what's A doing to these? Is it being added, subtracted, multiplied, or divided? Multiply. So what's the opposite of multiplication? Division. So we're going to divide both sides by little a. Those cancel out. And I'm just left with sine A over little a equals sine C over little c. Okay. Let's turn it over. I want to make sure everybody has everything written down before I turn it over, but if you are done, go ahead and turn yours over. We're going to start on the back. If you feel confident, you can work ahead of us. Okay, this time we're going to sketch an altitude from C. Okay, we're going to label it K again. All right, now we're going to create, we've created two right triangles where A is contained in one side, B is contained in the other, and we're going to write this all out again. So sine of A is K over B, and sine of B is K over A. Okay. We are going to solve them for K again. So we get sine A equals K over B. We're going to multiply both sides by B and get little b sine A equals K. And we're going to do that for sine B again. What are we going to get rid of on this side? For sine B equals K over A? What am I getting rid of? I want K all by itself, so I'm getting rid of the A. And A is being divided, so I want to multiply. So I'm left with A sine B equals K. Now it's asking me to set them equal to each other. Little b sine A equals little a sine B. Now it's asking me to regroup. So I've got little b. Am I going too fast? Little b sine A equals little a sine B. And I'm just going to divide this side by B, this side by B, this side by A, this side by A. And I'm left with sine A over little a, because these cancel and these cancel, equals sine B over little b. So far, so good? Okay. So what we're going to do is we're going to take what's on the front and combine it with what's on the back. And we end up with this whole equation, sine A equals sine B, which equals sine C. Sine A over little a equals sine B over little b equals sine C over little c. And we can use, we're always going to use two of these to solve a triangle. We're either going to just use the A's and B's, just use the B's and C's, or just use the A's and C's. And I'm going to show you how to do that. Okay, so why did we do all this? And am I going to make you do this on a test or quiz? First of all, no, I'm not going to make you do this on a test or quiz where you'd have to discover it. Why did I make you do it then? Okay, more and more as we get further up in math, so when you go to Algebra 2, when you go to pre-calc, definitely when you go to calculus, okay, you're going to have to more and more derive formulas, figure out how to get them, okay? This is deriving a formula, okay? So this is a very beginning how we start to teach how to do it. So you guys knew what sine was. We just divided a triangle in half to form two right triangles to find this formula, okay? So this is the beginning of deriving, coming up with formulas. This is like how the mathematicians did it way back when. Came up with it in the first place. Okay? So we are going to do this again with law of cosines, where we're going to derive it. You won't ever have to derive it on a test or quiz, but it's important for you guys to start looking at how to do that, because the further up in math you go, you might have to do it on a test or quiz where you derive it, okay? All right. Now we're going to use this in an application. So I need you guys to pull out your law of sines homework. Miss Murphy speaking. He is taking a test in Mr. Huan's room. Yep. Thank you. Bye. Okay. So you should have your homework out in front of you. And we're going to do an example problem. We're going to do an example problem. I'm going to do number 1. After I'm done with this. Okay. Well, it won't be very long. Okay, so we're looking right here at number 1. And we want to find AC. So the important thing with this is that you label the sides. The sides are going to be lowercase. The angles are going to be capital letters. Lowercase, capital letters. So AC is across from B. So I'm looking for little b. Okay? And I have side little c. The first thing I'm going to notice is I don't have angle C. Can I find angle C? Do I have the two other angles? So how would I find that third angle? I would go 180 minus 118 minus 22. And I get 40 degrees right here is C. Okay, so I'm going to use C, and I'm going to use B. Those are the ones I'm going to use. So I'm going to go the sine of C, sine of 40 over little c, which is 24. So see, I'm using sine of C over little c equals sine of B over little b. So I'm now replacing it with numbers. Sine of 40 over 24 equals sine of 22 over B. Everybody get how I set that up? So I'm literally looking for two things. I know I'm missing a side, so I know I'm going to have to use the angle opposite it. And then I need another angle and side that are across from each other. Okay? So that's why I picked C and B, because C had a side. Okay? Now that I have these, I'm going to just cross multiply. I get B sine 40 equals 24 sine 22. Okay? Now I'm going to divide by sine 40. And I'm just going to stick this in my calculator exactly like that. So I'm taking out my calculator and I'm going to put in here. I'm just putting in, I like to make the little division sign in there. And then I put 24 trig sine 22 divided by trig sine 40. And I push enter. And I'm going to get 13.9. It says Round the sides to the nearest tenth. So I'm going to get 14. That's my answer. Okay. All right, I want to do one where we find a degree. Okay, so let's go ahead and do number 7. So we're going to go all the way down to number 7. Okay, it says I'm going to find C. So I'm looking up here at the top. Do you see where I have the sines and cosines equation? So if I'm looking for angle C, I know I'm going to have to use C as one of them, right? Now I have to figure out if I'm going to use A or B for the other one. Okay. So I've got C right here. I know this is little c. Which other angle do I have, guys? A. So I'm going to have to use A. So I'm going to use A and C. So I'm going to go sine of A equals little a equals sine of C over little c. Okay, I'm going to stop right now. Do you guys have questions about how I picked those? If you don't ask, I don't know if you have questions. You okay with why I picked sine? Yes.
Why would I have B?
So B has no angle. That's why it's not B. That's a good question. Anybody else? Okay. Now we're going to fill in where it says big A, big C with all the stuff that I possibly have. So I'm going to put sine of what? What goes instead of A? What goes instead of A here? 82, good. What goes instead of little a? 29, across from it, right? Right across from it. What goes instead of big C? Do we have angle C? No, so we just put C. And what goes instead of little c? 20, because it's right across from it. So far, so good?
Yep.
Okay. Now we're going to cross multiply. So we get 20 sine 82 equals 29 sine C. Okay? Can I have that 29 over here? So I'm going to do what? What's the opposite of multiplication?
Divide.
Division. Divide by 29. Okay? Now I'm going to put this in my calculator. Yep. So I'm going to put in my calculator. I'm going to put the little fraction thing, 20 sine 82 over 29. And I'm going to get this number. I'm going to get 0.6829 equals sine C. Okay? Now, how do you think I get rid of sine and get C all by itself? How do I get rid of, if something's being multiplied by something, I divide, right? What if something's being squared? What do? You square root it. Do you guys remember that? Like if something's squared, you square root it. So if we have sine, we're going to use inverse sine. So you're going to go sine of -1, and you're going to put that there. 0.6829 equals C. And we're finding a degree, right? So if we're finding an angle, it makes sense to use that negative sign. 0.6829. So I end up with 43 degrees equals C. Okay, so I know that I've only done 2 examples, but the only way for you guys to get better at this is for you to try it on your own, okay? So if you look, 9, 8, 10, and 6 are just like what we just did, or that problem. So that just has one extra step. When you're done, you're going to have to take the inverse, okay? Where 2, 3, 4, and 5 are just like number 1. Okay? So set them up. For number 2, let's start with, you guys need to be able to write little b across from b, little c across from c, and little a across from a. So that's the first step. Should we write down steps? Do you want to turn this over and write the steps on the back?
Yeah.
Okay. Okay. Law of signs, steps. Okay, step 1. Label the sides A, B, C across from angles. Okay. Step 2. Choose which 2 parts of the equation to use. So we know we have, zoom out just a little. So we know we have sine A over little a equals sine B over little b equals sine C over little c. You know you're going to only use 2 out of those 3. Okay? Step 3, plug in numbers. Step 4, cross multiply. Step 5, I know you don't understand it. You will. We're going to keep practicing it. Step 5, you're going to divide. And then after step 5, you divide and you'd be done, unless this is for finding an angle. You want to take the inverse sine is your last step. So if you're finding a side, you're done at 5. If you're finding an angle, you're done at 6. Okay? Try to use those. Let me know if you get stuck. I'm going to zoom out a little bit and leave the steps up on the screen so you don't have to flip back and forth for your paper if you don't want to. Okay? I'll try to make this bigger. Let me know if you need some help.